So, as he said, my name's Nathan Keys. I work for Megatronics. I've been working there for about 5 years now, and I oversee most of our marine construction projects. And so we've been working with the Teledyne PDS software for about the last 2.5 years, and it's really been a force multiplier for us. You know, projects where maybe in the past we'd say, I'm not sure how we'd get that done. You know, we can use PDS to do that stuff. And so this is one of those projects. So as he said, it's the Tappan Zee Bridge in New York, and they're doing demolition. And that's interesting for us because demolition is not something that we've done too much of in the past, but you know, when these guys came to us and told us about, you know, what they're trying to do and what they need to do to get this demolition done and done properly, it's a really good fit for the sort of stuff that we sell and the stuff that PDS software can allow them to see. So a little bit of project background information. The Tappan Zee Bridge was originally finished construction in 1955. At the time, cost them $81 million. And it was designed with a 50-year lifespan. So anybody's quick at math, that's been a little bit ago. It was designed to hold 40,000 cars per day, and now it's doing closer to 140,000 cars. So you know, it's past its design lifespan. It's doing them 3 times the amount of traffic, and so the repair costs on it, they did a study, and the cost to just try and keep fixing it was really, really super high. So they decided, okay, we're just going to replace it. And so they went back and forth a lot on the replacement budget and what they want to include, but they ended up at just under $4 billion. And so that's the biggest one in the United States right now. And so you can see that's the old bridge there on the left, and then on the right, the new one going up next to it. Okay, so these demolition requirements that they had, they wanted to image with sonar the footers and surrounding debris around the bridge. So they want to know what's there and what they're going to have to pick up when they're done. So they're basically, most of the excavator work is going to be hydraulic jackhammering. So on concrete structures, they're going to use those jackhammers and cut it all down. For anything that's not concrete, there's some steel pile and some sheet pile and things like that. They're going to use excavator buckets to kind of come in and expose the sheet pile, so a lot of it is buried in the dirt, and so they're going to expose it down to their grade elevation so divers can come in and cut it off. And so they also want to periodically, you know, rescan and keep scanning, because as they're jackhammering and cutting these things off, you know, debris is certainly going to, you know, move around, and they want to make sure they have to go back and pick all that up. So that's what they're going to be doing with the scanning boat. And another big thing for them was they're going to be using different tools, right? So excavator bucket, jackhammer, and even a big shear on the excavator. So that's kind of like a big pair of scissors. And so, you know, having a software that can support these different tools was a big thing for us. So we went to them, and after talking and back and forth, we kind of decided this is what we needed to do. And so they got 5 excavators that they wanted to outfit with positioning, 2 cranes, and so after all the jackhammering is done and it's a big rat's nest of rebar and concrete, they're going to scoop it out with clamshell crane. We talked about 5 motion scan systems so that each excavator could have its own sonar, and we also talked about having a site-wide Wi-Fi network. So the site-wide Wi-Fi would allow them to see every vessel from every other vessel. They can share data back and forth very fluidly. As we went through more about the budget and things like that, we had to make some sacrifices. So we changed it to 1 motion scan boat, and so put it on a vessel this time, so the vessel can kind of service all 5 excavators, one at a time, as opposed to, you know, all kind of at once. And also the site-wide Wi-Fi got whacked, so we ended up doing individual sort of local Wi-Fi networks, so when the boat does pull up next to an excavator, they can communicate. Okay, so this is just a typical PDS software view, what you see here. So on the right side, the plan view there is color-coded based on the distance it is from their grade, okay? So if it's gray, it's above grade. Green and yellow is right in their grade tolerance, and red means it's below grade. Okay, so this is totally customizable. You can make any colors, any grade difference that you like. So we're also showing a few numeric items. So we're showing the bucket's elevation and the distance the bucket is from the current grade and the GPS status. The point is here, it's very customizable. If one operator wants to see, the plan view big, then we can show that. If they want to see the profile big, then we can show that. Okay, so this is the different equipment that we use to outfit the excavator. And so there's quite a bit, but basically it's GPS for position and heading. We're using Trimble angle sensors to do the excavator portion. So, on each arm of the excavator, we have to have an angle sensor so we can compute the bucket tip. And then we've got a PC in there that's running Teledyne PDS. We've also got the Wi-Fi adapter that I talked about so that, when the survey boat does pull up, they can communicate via Wi-Fi. It's really the only way to do it, to communicate with the boat. You can't run a wire to the boat, right? That's not going to work. All right, so the Trimble... Right, so the Trimble excavator here, and it allows them to do several things. So you can see here he's been making swipes at this surface. So the red is where he's already he's dug it down. But there is a small strip there that he missed as he was doing his swipes. And so, without the software, he'd be doing it Helen Keller style, right? Trying to feel where he's missed. And so with the software, he can see exactly where he's been, and he can go and get that one little strip. And so you can see it's updating. It'll update where the excavator bucket has been, and it'll take it away from the surface there in the corner, from the 3D surface at the top, and the plan view here on the left. And so as he's digging it through, it changes the colors because now it's below their grade, so it turns it red. Okay, so this is one of the excavators that they're using, and with the jackhammer on it. And so, like I said, one of their big deals was we have to be able to show these different tools. So inside of PDS, we were able to show the jackhammer, okay? And so PDS has a bunch of standard shapes in there, and one of them is a hammer. And so this was already in there, ready to go. You just select hammer tool, and here we are. One of their other tools was a shear, and so that's a picture of the shear on their big excavator there. And so PDS also has a cool feature where if you can draw the tool in as a DXF or in SketchUp, you can bring it in and use that as your visualization. So there wasn't a standard shear shape in PDS. It's not used as commonly. So we got a drawing from the manufacturer in SketchUp, and so in the software we were able to see that. And so just having that flexibility and that functionality where we can show these different shapes was a really big point for these guys. And so the shear they'd use if there's a pile kind of sticking up out at a weird angle and they need to cut it off, they'll put the shear right on it and they can cut it that way. Okay, so one of the things I said they wanted to do was go up to the wall and expose down to their grade. And so you can see down here in the profile view in the lower right and up in the 3D view, you can see the wall right there. And so he's going to come up right next to it with the bucket and sort of expose that so the divers can get down there. And so, in a normal, typical dredging activity, they're concerned with their grade elevation and they don't want to over dig too much because that's material that they have to dispose of but they don't get paid for. In this case, they're not really dredging, he's just exposing that area. So he's going to over dig quite a bit here and just make sure he gets it to that elevation, and then he just kind of dumps it off to the side. So it's kind of a unique one for us, but one that we're able to get done with the PDS software.
How are you updating the telemetry real time like that?
Yeah, so this is it's based on the bucket teeth. So wherever the bucket has been, it updates the surface to that point.
Oh, okay. It's kind of theoretical.
That's correct. Right now, we'll get to the end of the presentation and it won't be so theoretical. Yeah, so wherever the bucket teeth have been, it will get rid of the surface. But that, like you said, it's sort of theoretical, right? It just means the teeth have been there. It doesn't know if material sloughed back in. It doesn't know if you dump the bucket, half of the bucket fell back in, right? We don't know that. So we're going to get around that, though. Okay, so another thing we're doing is the clamshell crane for them. Similar, sort of, to the excavator, just different sensors. So we're still using GPS, and they all still have their own Wi-Fi. But we also have rotational encoders on the drums to keep track of how much line has come out, and that's how we do the vertical for the bucket. And so and of course, we've got a computer running PDS in there, and so with all those different sensors working, then you get something that looks like this. And so, totally customizable, but we've got 3D up in the right-hand corner, and so you can see the bucket come here, and that's an old survey of the area, and so you can see them come down here, and the dark gray area is the existing ground, and that blue kind of hatched area is the grade. So you can see them come down, make the scoop, and update the area. So the point is, when they go back and do a scan and they see a big pile of debris or something, they can move right to it and scoop it up. They haven't put the crane into production yet. They're still putting it physically together and getting it on site, but that's how we're going to be using it. And so the last thing, so instead of doing a motion scan on each barge for each excavator, we put one on a vessel. And so, with that, you have to have a little bit more serious motion control, right? So the boat is moving around a lot with the motion of the waves. And so we've got a Trimble MPS 500 on there to do position, heading, heave, pitch, and roll. Okay, again, Wi-Fi, and again, computer running PDS. Okay, so this sonar here, the number one there, the sonar is pretty cool because it's on a pan and tilt unit, which means that, a traditional multi-beam sonar just looks down and you move the boat. This sonar, we can, with a push of a button, we can physically move it, we can pan it around like this, change its heading, and we can tilt it up. So when they're trying to look up at the wall, or they're trying to scan a bridge footer all the way up to the water surface, they can do that from the computer. And so the sonar, when it's running, looks like this. So you can see it, you can turn it and change the angle and update surface in that way, rather than move the vessel like we would with a traditional multi-beam. So this is another project that we did where we had one of those motion scan units on the front of an excavator barge. And so you can kind of see there in the 3D view, there's some wire crossings, and they're highlighted in red on the plan view. And so when you're scanning, we can see those wire crossings. And, if you wanted to take that excavator bucket and scoop up the wire, in this case, they didn't want to do that. They were trying to do exactly opposite of that, right? But if they wanted to, then they could. And that's what really drew the Tappan Zee guys to this, where if they see a pile laying down on the bottom, they'll see it in real time and can move the excavator right to it, pick that pile up, and get it out of there. And so when you have the motion scan running, it goes like this. So the motion scan right now is doing a little circle, and in a minute, it's going to pop in there and update these colors. And so the colors, again, like we said, they're based on the distance from the grade. And so they'll know where they need to do some more digging, some less digging, and they'll be able to address that. And so the big strength here is it's multi-beam data and the excavator or the clamshell crane, whatever it is, it's all in the same world, right? So this data pops up and he can see that, okay, in this case, the red, he's got to do a little bit more filling in to get that red part up to grade. Okay? So it can work like that in 2 dimensions, and it can also work like this in 3 dimensions. So in this case, this is a little bit more what the Tappan Zee guys were looking for, so they can see this real-time 3D point cloud. And again, if there's a pile or a big piece of debris or a big rock or something like that, they can see it. Obviously, they can see their excavator bucket or shear or what have you, and they can move it right to there. And so you can see on the right, he's left a little mound of material, and then on the left, it looks like he's pretty close to grade. So he can see right there, and he can move his bucket over there and scoop it up. And so the Tappan Zee guys, very, very smart on their part. They got the stuff early. They're not actually starting the demolition until, well, I guess they're starting very soon. October 6th, they moved all the traffic off the old bridge onto the new one, the first lane to the new one, and they're going to start doing the demolition very soon. So they haven't put too much of this into use. They have been exposing some of those walls, but they're going to start working on that pretty soon, I'd say. And so this multi-beam sonar here, you know, it's not impervious to suspended material. A lot of times when you're digging, so you can see there, you know, it's imaging right where the bucket is, and there's all this noisy data, right? And so that's no good. We don't want any of that. So a lot of times what they'll do is they'll dig or do, you know, place material, let it settle for, you know, 30 seconds, and then scan it, and then it updates properly. So that's all I have. You guys have any questions?
Teledyne Marine. Everywhere you look.